Everybody, this is Digital Blackboard by Sachin Pinagmote. In this video, we are going to discuss network function, how to draw pole zero diagram, and how to find inverse Laplace for given function. So let's start. This is the problem. The voltage V of S for the network given by V of S is equal to 3S upon S plus 2 into S square plus 2S plus 2. Plot the pole zero diagram and hence find V of t. So step number one, in step one we will find number of poles and zero, and then we will plot the pole zero diagram. So we know that 0 is nothing but the value of s in the numerator of the given function, so that it makes the function is equal to 0. So the value of s in the numerator, so s is equal to 0. So if we put s is equal to 0 here, the v of s will become 0, and that's why we are having only one 0, that is located at s is equal to 0. Next we have to find out the poles. The pole is nothing but the value in the denominator of s, the value of s in the denominator, which will make v of s is equal to infinite. It means the value of s which will make denominator 0, and then only v of s will become infinite. So here we can see, if we put s is equal to -2, then whole denominator will become 0 and v of s will become infinite. And similarly, if we find out the roots of this s square plus 2s plus 2, this is complex equation, so s square plus 2s plus 2, we have to find out the roots. So its roots will be 2. So 2 plus 1, so there are total 3 poles. Okay, so we are having 3 number of poles located at s is equal to -2, then s is equal to -1 plus j1, and s is equal to -1 minus j1. So let's start with the plotting of poles and zeros on the s plane. So on x-axis we know we are having the real axis, that is sigma axis, and on y-axis j omega, that is imaginary axis. Then we are taking scale on x-axis and y-axis. So let's 2 unit 2 centimeter is equal to 2 unit on x-axis. Similarly, 2 centimeter is equal to 1 unit on y-axis. So here -1, -2, and again j1 and minus j1. Now first of all we will plot the 0. So 0 is at s is equal to 0, so that's why our 0 is lying on origin. So we have plotted the 0. Then we are having 3 number of poles. The first pole is at s is equal to -2, so pole has to be marked by cross and 0 has to be marked by a circle. So first pole we have plotted at -2. Then the next two poles are complex pole, because -1 plus j1 and -1 minus j1. So the next pole is -1 plus j1, it is here, its position is here, and next is -1 minus j1, so it is the next pole. So we have plot all the 3 poles and zeros, so just name it. So this is our pole number 1, so p1, this is p2, and this is our complex conjugate pole, that is p3, and only one 0 is available, that's why we are just naming it as z. So this is the first part. The first part of this problem is over. We have plotted the pole zero diagram. Now by using this diagram we are going to find v of t. So let's start. So to find a v of t, we have to use partial fraction method. So v of s is equal to 3s upon s plus 2, s square plus 2s plus 2. So as we are having 3, so we have to take 3 coefficients here, a upon s plus 2, plus b upon s plus 1 minus j1, and plus c upon s plus 1 plus j1. So we have taken 3 coefficients according to partial fraction method. Now we need to find out the values of this a, b and c. Okay, now to find out the value of a, b and c, we are having formula. So formula is for a, b and c is the h into vector addition of distances from 0 to pole upon vector addition of distances from pole to pole, and where h is a scalar constant. So it is already given in the problem equation, that is 3. So constant value of the numerator is nothing but scalar constant, so it is 3 here. So h we got already, that is 3. Okay, now we will put the distances from pole to 0 to pole and from pole to pole in this formula, and we will find out the corresponding values of a, b and c. So here case 1, to find a. So to find a at p1 is equal to -2. So we are going to find out the value of a at p1 is equal to -2. So for that again we will use the pole zero diagram. So now our p1, that is pole number 1, is under consideration. So all the distances will be measured from that up to P1. Okay, so the formula is A is equal to H into Z P1, that is distance from Z to P1 upon distance from P2 to P1 plus P3 to P1, because we are having 3 poles here. So we will use the same pole 0 diagram here. Now let's start with the distances. So we are drawing one line. We are drawing one line from 0 to P1. Okay, so this is the line from 0 to P1, because in the numerator this is the vector Z to P1. So Z to P1 we have drawn one line. So how much is this distance? So it is 1, and it is also 1. So 1 plus 1, 2. So Z to P1 the distance is 2. Now we will have to find out the angle also, because this is polar vector form. So angle we have to measure from real axis. Okay, so this is the angle is very single, so it is 180 degree. So when we have measured the distance from Z to P1, the distance comes to be 2 and angle comes to be 180. So 2 at an angle 180. So numerator is over. Now let's start with the denominator. So for denominator we will have to measure the distance from P2 to P1. So P2 is this pole. So from P2 to P1 we will draw one line. So we have to find out the distance this from P2 to P1. So again we got one triangle, that is right angle triangle here. So from the right angle triangle this distance is 1 and this distance is also 1. So if two sides are known, we can easily find out the hypotenuse. So the formula is c square is equal to a square plus b square. So that's why we are having c is equal to root 2. So we got the distance. So this distance comes to be root 2. Okay, now we will find out the angle. So angle we will measure from the x-axis. So this angle comes to be 135, but this is opposite, at the opposite side. So angle is minus 135. Okay, so minus 135. Then we have to measure the distance P3 to P1. So this is our P3. We will draw one line from P3 to P1. So again the distance comes to be, see, this is again right angle triangle. So this is 1, this is also 1. So this will come to be root 2. So the distance is root 2 and angle is plus 135. Okay, because we are keeping the protector in upward direction. So angle is 135. So finally we got A is equal to 3 into 2 angle 180 upon root 2 angle minus 135 plus root 2 angle 135. So let's solve it. So angle of minus 135 can be written as 45. Okay, minus 135 degree is nothing but 45 degree. So A is equal to 3 into 2 into at an angle 180 upon root 2 at an angle 45 plus root 2 at an angle 135. So A comes to be 3 into 1. So A is equal to 3. So we got the value of A. First coefficient A is equal to 3. Next we will find out case 2 to find B. So B has to be find out at P2 is equal to minus 1 plus J1. Okay, so again we will draw the pole 0 diagram. We will use the same pole 0 diagram to find out the value of P2. But now what will be the formula of that B? So B will become equal to, see, the B is nothing but distance from Z to P2 upon distance from P1 to P2 plus P3 to P1. Okay, so this is the formula to find out the value of B. So if by mistake it is written here A, but it is B. Okay, so we will measure the distance from Z to P2. So this is our P2 pole. See, this is P1, this is P2. So we will draw one line from Z to P2. So we are drawing the line. Now P2 is under consideration. So we are drawing the line from Z to P2. So what is the distance then? So again the distance is, this is right angle triangle. So this distance is 1. Okay, this distance is also 1. So we can easily find out this distance. So this distance come to be root 2. So we got the distance from Z to P2, that is 2. Now what is the angle? So we have to measure this angle. So this angle comes to be 90 plus 45. So this angle is 135 degrees. So 2 angle 135 degree, it is in the numerator. Then we will measure the distance P1 to P2. So we are going to draw the line from P1 to P2. We have drawn one line. So what is the angle? So angle is 45 degree from x-axis. Okay, so P1 to P2, the distance comes to be, again we have to find out that distance. So again this is 1 and this is 1. So this distance will again root 2 and the angle is 45. So we are having a root 2 angle 45. Then we will draw the line from P3 to P2. So this is P3 to P2. We are going to draw the line. So how much is the distance? So distance comes to be Again this is 1 and this is up to 1. So 1 plus 1 2. So we are having the distance 2, and angle is very simple here, that is right angle. So the angle is 90. So plus 2 angle 90. So finally we got B is equal to 4 into root 2 at an angle 135 root upon root 2 angle 45 plus 2 angle 90. So we can easily calculate B here. So 135, the angle will become 0 because 135 minus 45 minus 90. So angle is 0, and this is root 2 upon root 2 into root 2, so into 3. So we can easily calculate it by using calculator as well. So this root 2 will get cut. So finally B is equal to 3 by 2, B is equal to 1.5. Now we will use one trick here, as P2 and P3 are complex conjugate poles. So if B is equal to C is equal to 1.5. So only imaginary part sign will get changed, but as there is no imaginary part available in B. So B is equal to 1.5. So C is also 1.5. So we got the values of all the coefficients A, B and C. So finally we will put these values in the main equation. Okay. So our main equation is A upon S plus 2 plus B upon S plus 1 minus J1 plus C upon S plus 1 plus J1. So we will put the values of A, B and C. So V of S is come to be 3 upon S plus 2 plus 1.5 upon S plus 1 minus J1 plus 1.5 upon S plus 1 plus J1. Now taking inverse Laplace transformation, so it will become V of t is equal to 3 e to the power minus 2t, 1.5 e to the power minus 1 minus J1, again plus 1.5 e to the power minus 1 plus J1t. Okay, so we got the value of V of t. So I hope you understood this problem and you got clear, the idea is clear in your mind how to plot pole 0 diagram and how to find the function, that is V of t. Okay, so please like, share and subscribe this channel Digital Blackboard. Thank you very much.